Hi, I'm Kian, and today I want to show you how to prove if a series is divergent or convergent. So you have this question. It says you have a series from n equals 1 to infinity of an, and this converges. And you have another series from n equals 1 to infinity of bn. This also converges. And you want to know, is there a value or a sequence for an or bn that's the sum from n equals 1 to infinity of the product of an and bn can diverge. So first, we should give an example of a series an that can converge. So the prime example can be an be equal to negative 1 to the power of n over square root of n, which is converged by the alternating series. So I will make a video and prove it, but for now we know this has been proved that it's convergence. And also for bn, we can use the same example because it doesn't say that an can't equal bn. So also for bn, I would write the same example over square root of n. Now, we want to find if the product of these two, the sum of the product of these two can converge. So, if we multiply negative 1 to the power of n times negative 1 to the power of n in the numerator, we see that because the bases are equal in the power properties, then we can add these two powers. So negative 1 to the power of n times negative 1 to the power of n is nothing but negative 1 to the power of 2n. So we can write that the sum n equals 1 to infinity of an times bn is negative 1 to the power of 2n over, and square root of n from square root of n is just n. And now, in the numerator, if when you take a look at it, if we put numbers like 1, 2, we see that for every value of n, this value converges to 1. So we can replace 1 for it. If n be 1, we get negative 1 to the power of 2. And because the power is 2 times n, that means for every value of n, the power of the numerator will be even. That means and negative 1 to the power of any even number is just 1. So we can replace negative 1 to the power of 2n with 1. So we can write this as the series from n equals 1 to infinity of 1 over n. And this is a harmonic series. We can use, we can write it. We can write by p series that 1 is equal to 1. And because of that, we can conclude that this series diverges. And this is like one of the examples that can work. If we for example, it's a counter example for this. If we put 1 over n squared for an, we all know using p series, 1 over n squared converges, and it also converges to pi squared over 6. If we put 1 over n squared for both of them, and then find the product, we get 1 over n to the power of 4. And again, using p series, 1 over n to the power of 4 also converges. So it doesn't match the question we want. But this expression for an and bn works. Thanks for watching. Please subscribe and let me know what to do next.